Okay, we're going to look at the function y equals sine of x. And we're going to consider what the derivative of this function should be. It's not a power function. It's not in the form x to the n, so we can't use the power rule. We're going to have to do something else. So in order to try to figure out what the derivative of this might be, we're going to use our calculator. We're going to plug sine of x into our calculator. And in y2, we're going to plug in the n derivative tool. So math 8, right, of y1 with respect to x for each x value. And actually, first, let's just graph the sine function. Okay, make sure we see what it looks like. A good window is the zoom trig. The zoom trig automatically goes to a nice window for trig functions. So I hit zoom 7, right? And it looks like that. And it's our standard sine curve, right? So now we'll go back, and now that we have a look at that, we'll go back and look at what the derivative might look like. So we're going to do math 8, y1 with respect to x at each x value. Okay? And to differentiate what that looks like from sine, maybe we can make that a thick line or something like that. Okay? And there we have it. There's the derivative. And of course, it looks like a trig function. And even more, it looks like the cosine function. So we can ask ourselves, is y prime equal to cosine of x? Right? And we'll put a little question mark there for now. It looks like the cosine graph. One way to test if it's the cosine graph is actually plug in the cosine graph, cosine of x. Plug in the cosine function. And this time I'll maybe make this a dotted line or something. Okay, and now I'll make the cosine graph thick. And so we'll see, hopefully, the cosine will cover up the dotted n deriv graph. There's our n deriv. It doesn't look very dotted. And there's the cosine comes in right over it. So that's a little bit of confirmation. In fact, it's pretty good confirmation. It's not proof, though. The proof will come later. So another way to confirm that this is actually the derivative is to draw a tangent line to the cosine function. So in order to do that, let's draw a tangent line line at x equals 2. Okay? Oops. Let's get rid of that. Okay. At x equals 2. In order to do that, we're going to use the point slope form. Y minus y1 equals m times x minus x1. Okay? x1 is obviously 2. We're going to draw this tangent to the sine curve. So we want it on the sine function. So y1 is going to be sine of 2. Okay? And for m, the way we're going to test this is we're going to use the cosine function to find the slope. And if the cosine function gives us a slope such that this line turns out to be tangent to our sine curve, then that is more confirmation that the cosine is the derivative of sine. So the function is going to look like this then. It's going to be y minus sine of 2. Oops, there's that thing again. Get rid of that. Okay. So y minus sine of 2 equals cosine of 2 times x minus 2. Okay. Now to get this in our calculator, we're going to add sine of 2 to both sides, which is easy enough. I'm going to turn off this n deriv. I'm going to leave it in there, but turn it off for now. And I'm going to put my this equation in for the line. So cosine of 2 times x minus 2 plus, because we have to add sine of 2 to both sides, plus sine of 2. Okay, and this should come in as a tangent line. There's a sine curve, and indeed, looks pretty tangent. We can zoom in, and you can play around on your own with your own calculator to see that that is tangent. But we can actually do this wherever we want. Since we plugged it in real nice, we can plug in 3 for all these 2's. And graph that, and it should come in tangent somewhere else. Right? And it does, and we can do that as much as we want. And this is further confirmation, though still not proof. How about -2? And we can make this +2. Still not proof, but it's good confirmation that the derivative of sine is cosine. Whoops, that didn't work. What did I do wrong? This last one has to be -2. Let's try that. There we go. And that's that. Now, let's also look at the derivative of cosine of x. Okay, and we'll just delete these. And we'll look real quick. We'll turn my derivative back on. Okay, and let's make the derivative thick instead of dotted, because you can't really see those dots. There we go. And the derivative of cosine is a trig function as well. And it looks like sine except flipped upside down. And so we can go through all the same methods to confirm this. When we flip something upside down, that just means we add a negative in front of it. But what this shows us in the same way is that if y equals cosine of x, then y prime is negative sine of x. And you can play around in the same ways that we did with the sine function and confirm that for yourself. And just convince yourself that that's true, and then later on we'll prove it. But for now, we're going to use these as rules, and we'll prove them later. All right, the end.